Hi, welcome to the fourth live tutorial of Pyhealth. I'm Patrick Jiang, an MS student at UIC, advised by Professor Jimon San. Today, I will cover the topics of MapCode and Tokenizer, which are the two base modules in Pyhealth used for the data processing. So this is our development team. We currently have Chaoqi, Zhenbang, and me as the contributors, and our advisor is Professor Jimon San. We also want to express our appreciation to the previous team contributing to the old version of Pyhealth, who are Yue Zhao, Dr. Qiao, Dr. Cao, and Xiyang. At the beginning, I will briefly introduce the main components of our package. Pyhealth is a helpful package for both domain scientists and machine learning researchers. For domain scientists, they may follow our developed machine learning pipelines with the predefined healthcare predictive the tasks and models provided by our package. For the researchers who are familiar with the machine learning, they may use any of the modules provided by us and build their own pipelines. The package contains 4 modules. The first one is the EHR database module, which is used to unify different formats of existing EHR datasets like EICU, MIMIC, and OMOP. Prediction task module. This is used for this module contains a lot of task functions of various healthcare predictive tasks like drug recommendation, mortality prediction, and others. And we'll also have a machine learning core module, which contains the traditional machine learning models like random forest, MLP, and common deep learning models such as CNN, RNN, and transformers, as well as some the healthcare deep learning models such as Retain, GameNet, and many others. We also have a EHR code mapping module, which is the one I will introduce today. The main purpose of this module is to map the medical code from one coding system to another, and we will discuss in detail in today's tutorial. Yeah, so let's get started. First off, I will introduce medical code. Here, I reuse the example here, which Zhenbang used in the last tutorial for the illustration. This example is EHR data of a 77-year-old patient who was transformed from the emergency department to ICU and then to the general hospital admission. No matter in which places, the conditions and procedures and medications are recorded. Besides the representations of names in natural language, these terms can be represented as code regarding the coding systems they use. For example, here we use I82.40 for the acute embolism. And we use, like for another example, we use I5021 for acute heart failure. Currently, we have we have many coding systems. For example, for diagnosis, we have CM, procedure, acid norm, or ATC. So the codes for the same term in different coding systems may be different. For example, the code of congestive heart failure is 428.0 in ICD-9-CM and 108 in CCS-CM. So yeah, this is the brief introduction to the medical code. So the task we concern is the code mapping, namely given a term in either conditions, procedures, or medication, we map the code of it from one coding system to another. For example, for the previously mentioned congestive heart failure, our goal is to map it from the ICD-9 coding system to the CCS coding system. Here's the question: why do we need the code mapping? One of the most important reasons is that the code in some coding system is too fine-grained. Like if we use the medical code in fine granular to train our deep learning model, the embedding space would be super huge, and the trained model often could not perform as good as we expected. So in such case, if we map the fine-grained code to a more coarse-grained one, the model can be trained better. For the example shown here, the ICD-9-CM has many poisoning types with the parent code 975, and all of them can be mapped to the coarse-grained type, like the 242 in the CCS coding system, where the poisoning by other medications and drugs is a more generalized name for this code. So after introducing the background, I will move on to the introduction of map code in Pyhealth. So the left graph shows the current structure of the map code module. The InnerMap and the CrossMap are two general classes, cover most common functions, while the code for the specific vocabularies have some customized functions. Let's start from the InnerMap. In our package, InnerMap is a base abstract class for all map coding systems. You can use this class to get any inner information of a coding system. We use the load function to initialize the InnerMap with a specific vocabulary. For example, here we initialize InnerMap with the ICD-9-CM, which is a vocabulary for conditions, as we previously mentioned. Of course, you can load any other coding system by input a vocabulary name here. So after the load function is called, it will download the corresponding CSV table from the Google Cloud server of Pyhealth and store it as the pandas data frame locally. So if you call it again, the data will be loaded from the local environment. So this is the initialization of an InnerMap. Once an InnerMap is initialized, you can use its function to check the inner information. For example, you can use the Lookup function to check the name of a medical code. You can use the get ancestors to check the parent codes of a medical code, and get descendants to check the child code of it. For example, for the 428.0, you can by using the Lookup function, you will get congestive heart failure. And for the 975.1, if you call the get ancestors, you will get all the parent nodes of it. Yeah. So for some specific coding systems like ATC, we also provide the additional information from the drug bank. You can simply input a second argument into the Lookup function to specify which information you want to get. For example, if you put drug bank ID as the argument, you will get the drug bank ID for that code. Similarly, you will get the description by input the description. Yeah, so after the introduction to the InnerMap, I will introduce the CrossMap here. The CrossMap is the main class we use for the code mapping. So for CrossMap, it is a base class for all possible mappings, and we also use the load to initialize the CrossMap, but slightly different from the InnerMap. We input a source vocabulary and a target vocabulary. Yeah, for example, if you want to map the code from ICD-9-CM to the CCS-CM, you should input them correspondingly to the source vocabulary and target vocabulary. And then the load function will trigger the initialization to download and read the processed mapping file stored on the Pyhealth Google Cloud. Once a CrossMap is initialized, you can do the code mapping very easily by calling the map function with the code you want to transform. So basically, that's it for the introduction to map code. And I will go over our tutorial notebook to show you how this works. So yeah, so to get access to our package, you can just Google Pyhealth, and the first thing would be our website. And you can get access to our tutorials by clicking on tutorials on the sidebars. Yeah, so our topic today is map code. So I'll open map code. Yeah, so after opening this notebook, let's first get started by installing our package. So you can simply do it by pip install Pyhealth. Yeah, so there are several instructions we just went over, and we can directly jump to the example. So this is the first example. The first step is to import the InnerMap if you want to use the Lookup function in our package. And you can just import the InnerMap and initialize it with, You can initialize it with the load function, what I just mentioned. And yeah, so run it. Yeah, so this instance, ICD-9-CM, is initialized with the vocabulary just specified, the ICD-9-CM. And if you want to check if a code is in the vocabulary or not, you can just use the in to trigger the contain function that built in our InnerMap. So it shows true here, means the 428.0 is in the ICD-9-CM. And if we call the lookup function by input the code, we'll get the information of name, because the default the default here, the default value for the second argument is name, and yeah, it will return the name of this code. And if you want to get the ancestors of this code, you can get its parent nodes. And for its child code, like if we input the 428, you'll get all of the children nodes of it. So yeah, and we have a built-in standardized code for the input. For example, if the input to the lookup function is not standardized, like we use the 4280 here instead of the 428.0, it will automatically normalize it. So it will return the same thing, just as the one we tested before. So, yeah, so there are several to do that you can try it by yourself. Like we have mentioned that we can initialize InnerMap with a specific vocabulary. So we can initialize another InnerMap called CCS prog, for example. It will be loaded and Patrick, can test the lookup function. Yeah.
Can I ask a quick question? This is really cool. Is there an easy way to find what are the different map coding system that we support?
Yes, so
CCS prog, right, in order to initiate this.
Yeah, so currently we support the ICD-9, ICD-10, and CCS for the diagnosis code and procedures codes. And we have NDC, RxNorm, and ATC for the medication codes so far. Yeah.
Right. So they have to kind of know the names exactly, right, to initiate this. Right. I wonder if there's a like list all the coding systems, right? That could be probably beneficial.
Yeah. We will update that soon. Yeah. So I will jump to the second example, like the lookup ATC code. As we mentioned, for ATC, we have the information, like the additional information from the drug bank. So we can do the similar thing, like if we load ATC with the lookup, load ATC to initialize this InnerMap, and we can look up the information of this code. So it's ibuprofen combination, and since it has additional information, we can specify the second argument, like the drug bank ID, like it will return the drug bank ID, and for description and indication, as well as the smile string. Yeah, we can. So for the ATC codes, you can check it from the website here. Yeah, so here's an example, like if we test this one is for the aspirin, and we can check it indication, and we will check another example by looking up a random code here, like for example, yeah, we'll test this one, like the can just copy and paste its code and right. So look up, and we input the first argument as the code. And for example, if we want to know its drug bank ID, it's shown here, and we set the second argument as drug bank ID. It will return the same thing here. So it is super powerful if you want to use our map code to search for some drug bank information with the codes in some coding systems. So after introducing the InnerMap, I will introduce the code mapping by our CrossMap.
For the ATC, this is really cool. I wonder, I thought the ATC has a different level. So I guess in this part, can you also access different level? Like if you want to aggregate to a higher level code, is that something?
Yeah. So just a second. So we support different levels for ATC code. We have a built-in convert function, like so if you want to use a certain level of ATC code, you can like ATC dot convert with the arguments like the first argument is code and the second argument is level. Yeah, so it will returns the certain level, the code in the certain level of APC with this function. And yeah.
Thanks. This is really good. Thank you.
Yeah. So yeah, I will introduce the code mapping with our CrossMap. So here's an example, like what I have introduced. We initialize the CrossMap by a source vocabulary and the target vocabulary. This example shows how we can map the code from ICD-9CM to the CCSCM. So we initialize it by input those two vocabularies, and we map the code we want to map, like the 428.0 here. So, but simply run it, we can get 180, which is a code in the coding system of CCSCM. So to check the correctness of it, we can initialize another InnerMap with the CCSCM because it contains all the information of that coding system. So yeah, we can simply check that, like by using the lookup function, it will return the name of that code, which is congestive heart failure, which is consistent to the 428 here in the ICD-9CM. Yeah, so yeah, we have another example, but yes, we can try that, but this one will take a bit long. And yeah, you may try it yourself, or I can. Okay, yeah, so yeah, to map the code from NDC to the next norm, we would do the similar thing by specify the source vocabulary as NDC and the target vocabulary as RX norm. Yeah. So that's it for the map code.